In this video, you will learn about central angles and inscribed angles of a circle. Alright, let's discuss about central angles first. Okay, the vertex of a central angle, which is this one, is at the center of the circle. And the angle formed here, in this case angle 1, is formed by the radius of two radius of the circle. It's radii, and it is just equal to the intercepted arc. So the intercepted arc here is arc AB. So this is what we call intercepted arc. So the measure of angle 1 here is just equivalent to the measure of arc AB. Say for example, we're given this problem here. Let's solve for the central angle. The value of the central angle given its intercepted arc, that is equal to 120 degrees. Therefore, the central angle here is just equal to, is also equal to 120 degrees. Now let's talk about inscribed angles. Alright, an inscribed angle is an angle whose vertex is on the circle and whose sides contain the chords of the circle. And then we also have the intercepted arc, and this is the arc that lies in the interior of an inscribed angle and has endpoints on the angle itself. So we have intercepted arc AB here. And the measure of the inscribed angle is just 1/2 of the measure of the intercepted arc. There are 3 cases of inscribed angles. Okay. The first case is when the center of the circle is on the side of, say this is, okay, is on the side of the inscribed angle. So this is the center of the circle. Alright, so our inscribed angle here is this one. So this is the first case where center O of the circle is on a side of the inscribed angle. The second case, right, the second case is when the center of the circle is inside the inscribed angle. Let's say this is the center of the circle, center O. Then wait. All right, our inscribed angle here is this one. So this is the second case where center O is inside the inscribed angle. And then the third case, okay, let's say this is the center of the circle O. The third case is when the center of the circle O here, in this case, is outside the inscribed angle. So all of these are cases of inscribed angles. So you can solve the same way. It is always equivalent to half of the intercepted arc. So if this is our inscribed angle here, the intercepted arc for this is this one, from this point to this point. And then in this case, this is the inscribed angle, and then the intercepted arc is from this point to this one. And in this case, we have this one as our inscribed angle, and our intercepted arc is from this point to this point here. All right, let's try solving some sample problems. Right. Let's say we're given this problem here, and we're given the value of the intercepted arc, which is 120 degrees. So we solve for the value of the inscribed angle. Let's say this is x. So x is just equal to 1/2 of 120 degrees. So this is just equal to 60 degrees. How about if we're given the angle, inscribed angle, and then we solve for the intercepted arc. Let's say this angle is equal to 80 degrees. So that would be 80 degrees equals 1/2 of, let's say this is arc AB. Okay, the measure of arc AB. Therefore, the measure of arc AB is just equal to 80 degrees times 2, which is just equal to 160 degrees. Alright, let's solve some more problems on inscribed angles. Let's say we're given this problem. So we solve for the value of x. X here is the inscribed angle, and we're given the intercepted arc, which is equal to 110 degrees. So x is just equal to 1/2 of 110. Therefore, x is just equal to 55 degrees. Okay, let's solve another one. All right, what if we're given this problem here? We're given the inscribed angle, which is 35 degrees, and we need to solve for the value of y, which is the intercepted arc, and x here is also an inscribed angle. So let's solve for x first. All right. Okay, one side of the intercepted, the inscribed angle x is on the center of the circle. So that means this one, the intercepted arc, is just equal to 180 degrees, since this is half the measure of the circle, which is 360 degrees. Therefore, x here is just equal to 1/2 of 180 degrees, which is 90 degrees. So this is the value of x. And now we solve for y. So we're given the inscribed angle 35 degrees is just equal to 1/2 of the intercepted arc y. Okay, therefore y is just equal to 35 degrees times 2, and that is equal to 70 degrees.